If you've ever driven anything with an engine, then doubtless you're aware of this thing called a starter. Often called a starter motor, or sometimes linked with this thing called a starter solenoid, this is the device that's responsible for getting the engine up and going when you need it. But how does it work? What's inside of it, and how does it actually do the starting of the engine? Well, let's take a look at what's inside, and maybe we'll have a little bit better understanding of how it works. So come on, let's go start some engines. Now, it's probably worth mentioning right here that not everything with an engine has a starter, especially things with small engines, like small push lawn mowers or chainsaws, weed eaters, those kind of things. You pull a string to get them started, and that gives them some rotational energy. But for bigger motors, it's really the starter that is able to provide the amount of energy required to get the thing up and moving in the first place. But what's inside of it, and how does it actually work? Now, this relatively small one is a starter motor. Inside of it is actually a DC motor. On some starters, there's another action that's required to elevate this small gear up into place to be able to mesh with a large flywheel gear on the side of the engine. Now, this doesn't have a mechanical motion to be able to move it. It simply has a spring that pushes it back into a relaxed position when it's not moving. So it doesn't need any extra electrical energy input, but some of them do. They require an extra push to be able to get them into the right position. That's the thing that's called a starter solenoid. That provides the action that actually meshes this tiny little gear with the large gear that's inside the engine, the flywheel. But regardless of whether it's got the solenoid or not, inside of this is a motor, so therefore the starter motor is an essential part of giving it that rotational energy to get started. I guess another really important question would be, why does it need to get started in the first place to get your engine up and running? Why can't you just deliver that spark from the spark plug and that begins the rotation? Well, the problem is when you stop an engine, it's not necessarily stopped in exactly the right position. Therefore, none of the cylinders are in the right spot to be able to inject a new fluid mixture of the gas and air mixture and combust it, which means the spark plug burning it, at the same time without somehow getting it to be able to go through that cycle that it takes to get the fuel-air mixture into the cylinder and then compress it and then be able to ignite it and begin the engine actually being able to do its job. So somewhere along the line, it's got to get that rotation to get it moving. Now, in older vehicles, like you see those old black and white movies of the Cars or old airplanes, somebody had to be standing in front of it with either a big crank or they'd grab onto the propeller and give it a spin, and that basically acted as the starter. Well, if we tried that every time on a car engine, there's enough compression in there that it would take a lot of force to get it starting in the first place. Well, that energy now comes from this starter motor. But as you can imagine, that takes a huge amount of energy, especially for bigger engines. So the power that we have to deliver to that starter motor is tremendous. That's why the battery in a car, that lead acid battery, has so many cold cranking amps, that ability to deliver so much energy to the engine that this tiny little motor can have enough power to spin an entire engine for enough of a cycle that it takes to be able to inject, fire, and then get the rest of the cylinders up and running. So that's why giving it that rotational energy in the first place is even an important part of the whole getting the engine started process. So now that we know that, we can go look inside the starter motor and have a little bit better understanding of why we need it to do its job. So I've taken the back two screws off of this starter motor casing, and I pull the back off, and now when I take the front and pull the front off of it, I'm going to see the inside of a motor. Now, this is a DC motor, which means on the back of this motor, right back here, we have the part that engages with these things inside, which are called the carbon brushes. The carbon brushes are inside that motor, and they allow the electricity to flow from the outside, which here's the terminal that would connect coming from the battery through the starter relay. And that electricity goes through these carbon brushes and provides the electricity to these large wire coils inside the motor, and those coils cause this motor to spin around the permanent magnet, so they call this a permanent magnet DC motor. And look at the size of these wires in here. The size of the wires is very large. That means they have very little resistance, and therefore there's a lot of current. And that's why we need that battery to supply that huge amount of current that's required to get that motor to actually rotate. Now let's take a closer look at this part of the process. This part up at the end is the part that actually engages with the part of the engine that's starting. That's called the flywheel. The large gear that's attached to the side of the engine is called the flywheel, and it gives that engine enough momentum to be able to spin. But it's a huge gear. This one is really small. Now there's an important thing to notice here. Hopefully I can get the camera to focus on it right, is that these are made out of kind of a softer material. And that softer material tends to get kind of chewed away. So there's some chips in all the little teeth of this gear. Now some might say, well, that's a really poor design. Make it tougher, make it not break. Well, tell you what, which would you rather have go out? The material in here or the material in the flywheel? Would you rather have to tear apart your entire engine and replace that? Or replace the starter motor? And remember, the starter motor honestly does not get used that much. So whether this is made out of some hardened titanium steel or whether it's just a really hard polymer like this one, probably doesn't really matter that much. However, if you were to try and reach over and press that start, get that gear or the key a turn while the engine is already moving, you're trying to get a moving gear to mesh with another moving gear, and you're going to get this awful grinding noise, which hopefully is a reminder to let go of the key and stop trying to turn it. But that's what can cause a lot of damage to that starter motor. So please do not turn the key and get that thing moving again, try to start it again when the motor is already started. But that noise should definitely alert you that something's up. Now I want to go back to that idea of the solenoid thing again. Now, if you look closely at this one, there's a tiny spring in here that when that motor starts spinning very, very quickly, the force will push this up into place. That'll happen automatically. For larger ones, it doesn't have a spring that relaxes it back into position. It has a separate device that's called a solenoid, which is an electromagnetic coil. It sends current into that coil and generates a magnet that pushes something up into place. That solenoid is what causes this gear to move out of its position while it's rotating and mesh with the bigger gear. So there's actually two actions happening in a starter. It's both rotating and it's moving linearly, so rotation and linear motion, to be able to mesh with that big flywheel gear. So both of those actions have to happen, otherwise your starter isn't going to work. If you don't have enough power in your battery to be able to do that, chances are it's not going to turn, but that solenoid might still work. So what you might hear instead on your vehicle is just this really loud click. So it's trying to engage the starter. It can click into position, but there's not enough power or current in your battery to be able to spin it. So you just get this click, click, and that's why that sound that you get is your battery's dead. And there's also other like relays and things like that that are probably trying to click, but it's that starter that's trying to engage and does not have enough power. This is that power hog that needs the battery to be charged when you park so that the next time you go to start your car, you have enough power to be able to do that. So that's the scoop on starter motors. You may have heard that sometimes you can get a failing starter to work by tapping on it with a hammer or something hard. Well, that works sometimes, and it's because the solenoid that engages it with the flywheel, once that begins to wear out, it can't properly mesh with the flywheel. It doesn't quite go into place and mesh the teeth of the gears together. But if you give it a little bit of a tap, enough of a shock to be able to engage those teeth, then it can work. Doesn't always work. And because it worked once doesn't mean it's going to continue working. If it's starting to go bad, you should get it replaced. But that is a procedure that is sometimes known to work. So that's how starters work. The next time you go to start your lawnmower or start your car, now you'll have a little bit better idea of how that works. For those of you who are interested in knowing how a motor is able to run that doesn't have a battery, hang on for just a second, and I'll show you how we can generate that spark plug and get that engine started without having a large battery, like you see on chainsaws and weed eaters, things like that. For the rest of you who are just here to learn about starters, now you know a little bit more about them, and I hope you have a great day. So stay tuned and give me just a second, and I'll show you how we generate the spark in a non-battery engine. So on this small engine, I've got this little device right up here where the flywheel is attached, the flywheel that you give a spin to with that pull handle, and it begins spinning. And this thing right up here is called a magneto, which I think is pretty neato. Sorry. But it's attached to the spark plug, and as that flywheel spins around, that flywheel has a chunk of iron attached to the side of it that when it passes through this field right here, this is basically the secondary core of a transformer, it generates a quick spike of voltage, and that sends a spark off to the spark plug. So we don't need a battery to supply the spark, therefore we don't need an alternator, we don't need to keep your chainsaw charged over the winter, you just go out and give it a pull and it starts. But if you've got a starter, that means you're going to have a battery, which means the battery is what's supplying the electricity for those sparks. So that's just an extra cool tidbit about the engines and how you get that spark without having a battery. And it's certainly related to that battery power that's needed for those starters. So now you know a little bit more about the engines. Go have a great day.